Now we're going to jump into the roof, ceiling, and attic portion of the load calculation. So I've already done this, already did this in the beginning, but there's a couple of other things, like a little more details that you really need here. So what we're going to do is we are going to, this will actually probably be a pretty quick one, but what we'll do is we'll do the global select all the rooms again. Yep. Left click on building right here. Right click, select all rooms, hold shift, take the garage out, and then right click. We've done this before, but this time we're looking for something a little bit different. We are looking for your duct heat loss factor and duct sensible gain factor. Okay, so we already added our insulation values and all of that. Now that's separate from what we're about to do, which is we're about to tell the program what condition the ductwork is going to exist in. And it makes a big difference because your ductwork exists in a very stressful environment in an attic in this application. And so we need to make sure we tell the program what that's going to look and feel like for the ductwork, because one of the largest loads in your house is going to come from, at least in an vented attic, from the amount of duct gain and loss, which is literally heat gain or loss from the ductwork just by means of it existing in a really hot and humid environment. So go ahead and click duct sensible gain factor, and we're going to walk through these one at a time. So you're going to notice right off the bat that you have supply, duct load supply, you have duct load return. And so it is true, two things can be true at the same time, that you can have return ductwork existing in one set of conditions and supply ductwork existing in another set of conditions. It's not the case on this application, but it is possible that you could have a closet unit and that return would be in a conditioned space and supply would be in an unconditioned space. But we're going to talk about the different materials. So you've already told the program this for the manual J portion, but this really affects the manual D portion, or it intertwines with the manual D portion. And just pay attention here. You've already selected a lot of this stuff. You just want to make sure that it's the same as the selections that you made earlier. Notice that there is radiant barrier, asphalt, tar and gravel, metal membrane, wood shake, all these different options. So in this case, we are asphalt, dark shingle on both our return and our supply. Make sure those selections are correct. And then look at your configuration here. And this is the single most, how would I say, impactful selection. One of the two most impactful selections that you can make on a load calculation. If you are to put radial, let's look at the supply first. If you are to put configuration radial perimeter outlet, what this means is that you are telling the program that you're going to have longer than normal duct runs, like actual linear footage, length of duct, because you're going to put every supply outlet on an exterior wall. And so it's just telling the program that you need to account for much longer duct runs, and that creates much greater surface area for heat to either be absorbed into or to be lost from. It's a calculation, it's a guess on the program's part, but it makes a huge difference in the duct load, which can, because it's the biggest load on the entire application at this point, it can swing your load by quite a bit. A half a ton, almost to 3/4 of a ton sometimes make that big of a difference. It literally the difference between some instances you choosing a 3-ton or a 4-ton system will be this selection right here. So in this case, Just decide, like, what is your preference? Do you prefer putting outlets on the exterior walls, or do you prefer putting them on the interior? If you prefer putting them on the interior wall, then left click, drop it down, and put radial center of room outlets. Done. Now, for your return side, this configuration is a little bit different. Try that again. Right here. Radial close to unit. This means that you have a single return air duct and it is really close to the unit, which means you have a really short return run and there's not a lot of surface area for heat to be either gained or lost from. All right. In this case, we're probably going to have multiple returns and it may not be close to the unit. So we're not going to put close to the unit. We're going to put radial, and that's going to tell the program that we have quite a bit more surface area of return duct to account for, and therefore that's going to drive our heat load up a little bit. Now, again, this is where a lot of people make mistakes when they do load calculations. They don't pay a lot of attention to this, and they may put all of their outlets on the interior wall, but then set it to perimeter outlets, and then it just creates this huge buffer and causes them to oversize systems by a half a ton, sometimes more. This is also the place where you need to put in what the R value around your ductwork is going to be. In this case, we're using R8 flexible ductwork. So we're going to change these two values here to R8 here and here. And our discharge temperature, Manual J says that if it's electric, it's 120, and if it's gas, it can be up to 130. The discharge temperature, if it's sized appropriately, this is going to be probably a heat pump, so I'm going to leave it at 120. Look at your ceiling. This is your duct ceiling, average. There's a lot more that goes into this and selecting this. I'm going to leave it at average for now, but I'll show you towards the end of this how to calculate exactly how much that is and how much it's affecting your load. Just know that a lot of people want to be pros and I seal my ductwork really tight, and they want to put it to extreme. And I'm here to tell you that once you actually calculate how much duct leakage extreme really is, you might be the 1 out of 100 that get the duct leakage test that tight, but most likely you're not. So be reasonable here. I will show you how to calculate what that actually looks like so that you know how to do that. But for now, we're just going to leave this at average. Your ambient temperatures. So these are the temperatures at which the ductwork is going to exist inside of the attic. Heat in the summer. Nope. In the winter, it is your 43-degree temperatures in the attic is typically what they're saying is going to be average. In the cooling season, it will be 129 degrees in the attic. And then you have the surface area of the duct. So this goes back to choosing center of room or perimeter outlets. Let's watch. Right now you have 174.8. Change it back to perimeter outlets, and the surface area is now 337.5. So it doubles the amount of ductwork in your attic that the program is accounting for when it comes to heat loss and heat gained through that duct system. So it's that's why I keep coming back to it, because I can't stress enough how important this selection is. Literally the difference between you oversizing a system, not oversizing a system. All right, so we're going to go ahead and put that back to center of room. I do want to go ahead and call out while we're here that if you're not using radial, which is flex, you're using trunk and branch systems, there are selections. Exact same theory, just says trunk and branch perimeter or trunk and branch center of room. So if you're using a trunk and branch system, go ahead and select that. If you look at the bottom here, you have the results of your attic, and you have your heat loss, heat gain, latent gain. So you have your loss in the winter, you have your sensible gain in the summer, and you have your latent gain in the summer. This is what it is calculating that the gain and loss is going to be through the ductwork, how much gain and loss is going to happen through that ductwork in their relative seasons. Again, if you change to perimeter outlets, you can see that it does change these quite a bit. Duct gain goes way up. Keep coming back to this because it's just that important. And so this is a different roof, ceiling, attic load form, and just as important, makes a big difference. So one is for the house itself and how heat moves into the house, and then this one is more for the ductwork and how heat moves into the house via the ductwork, right? And so both are important, both we have to pay attention to. And this is a very important, critical, crucial selection screen to make sure that you get right so that you can have accurate load calculations. Now, really, that's it. We have covered how to build the envelope, windows, doors, insulation values. We've now gone into the duct load, the duct gain, the ceiling, and all of that. So we've made it quite a ways into probably about 60% of the way through the actual manual J process at this point. More than halfway there for sure. So a couple more sections and then we'll be through the manual J, and then we'll move on to the manual S. But we're going to pause right here, take a break, and we'll move into the floor, foundation, infiltration and ventilation screens, and then room by room definitions after this.